Hi, this is Wissel from onyourweather.com. In this video we're taking a look at wind, what it is, how it develops, and also looking a bit at its characteristics. Well, I think it's fair to assume that everyone watching this video has experienced some kind of wind, whether it's been a light sea breeze, whether it's been a bit of a gale force wind, or even a strong hurricane strength wind. You all have experienced some kind of air movement, and that is exactly what wind is. Wind is a movement of air from an area of high pressure to an area of low pressure. Now that is all the result of the air having weight, and that results in a high pressure area or a low pressure area. Now, is that the only reason why wind can form? No. There are other reasons as well, or other factors involved. You can look at the Coriolis effect, which is due to the rotation of the Earth, which causes wind to deflect to the right in the northern hemisphere, to the left in the southern hemisphere, and can also be responsible for different kinds of weather systems. Gravity also plays a role, since air has weight. It's not empty. So the wind you're experiencing in the evenings rolling down a mountainside or a hillside, that's due to gravity. So there are different factors involved, but primarily the difference in air pressure is what's causing air movement, which you experience as wind. So let's just look at the definition itself of what exactly wind is. Wind is the large-scale movement of air from an area of high to an area of low pressure in the atmosphere. The speed and strength of the wind are determined by the distance between the low pressure and high pressure areas, also known as pressure gradient, as well as the difference in air pressure. This is the definition. We'll start breaking down the separate components shortly. Okay, so now we've defined wind, but we have to look at how wind develops in the first place. How is it possible for air to start moving from a high pressure to a low pressure system? Now clearly both these high pressure and low pressure systems has to be present, but another important thing you have to take into consideration is the fact that all air in a troposphere anyway has weight. It's not empty. Let's have a look. Air in the troposphere, the layer of the atmosphere we live in, always contain a certain amount of gas molecules as well as other particles. About 78% nitrogen, oxygen 21%, argon about 1%. Then it also contains a certain amount of water vapor as well as dust and pollen particles and other gases like carbon dioxide. So it's never empty. It always contains a certain amount of these gases which have a varying degree of weight. Okay, so clearly, although we can't see it, all the air around us has weight, which is responsible for the creation of high and low pressure systems. Before we get to the creation of a high and low pressure system, if anything in this video is a bit unclear to you or you need additional information, I left a link to the full article in the description below this video, which you can go and read on your own time if you need any additional information. Okay, so all air has weight, but it's the way in which the particles within any body of air responds to either heat or cold that causes the creation of a high or low pressure system. So let's have a closer look at exactly how a high and a low pressure system is created. When the temperature is cold, the particles or gas molecules within the air are less energetic, so they oscillate or vibrate or move around much less, so they don't require as much space around them. In other words, more of these gas molecules, dust particles, can fill a certain volume of air, which increase its weight, which results in a high pressure system. When the air is warm, however, the particles and dust molecules are a lot more energetic, so they oscillate, move around a lot more, they require a lot more space, so fewer of them can be found within that same volume of air. In other words, a low pressure system occurs. One thing you should always remember is the fact that wind always moves from an area of high pressure to an area of low pressure. Now, as this illustration clearly indicates, over the ocean, the cold surface causes the air to contract, or the particles within a volume of air to contract, weighing more. As a result, a high pressure system occurs. Over land, however, the temperatures are warmer, so particles within the same volume of air, much more energetic. So there's more space in between them, so they weigh less. And as a result, wind moves from a high pressure area over the ocean to the low pressure system over land Another way of explaining it is by using the analogy of a balloon. When you blow a balloon up, you create more pressure within the balloon as the air compresses within the volume of air within a balloon. As soon as you open up the opening of a balloon, the air quickly escapes and blows out as the balloon deflates to equalize the pressure. In other words, it blows from the higher pressure within the balloon to the lower pressure outside the balloon. And that's exactly how wind reacts and moves from an area of high pressure to an area of low pressure. Now, during the introduction, while defining what wind is, we briefly touch on the pressure gradient, and that is an important factor for determining the strength or the speed at which wind travels. Now, what you see on the screen right now is called isobars. You probably saw it during weather forecast as well on weather maps. That just indicates the pressure gradient, or how closely or how steep or how slight, if you want to call it that, the pressure gradient is. The closer these lines are spaced together, the steeper the pressure gradient is. In other words, the faster the wind will blow. The more space there is between these isobars, the less steep or the more gradual the gradient is. In other words, the wind will blow much slower in this case. Well, obviously a number of forces are at play, and quite a few factors are involved in the creation of wind, its characteristics, how strong it blows, etc. And that brings us to the different types of winds. There are basically 6 categories you can classify winds in, from global circulation to more localized winds. Let's take a closer look. Various criteria are being used to classify your different types of wind, including scale, how big it is, location, where it occurs, as well as its specific characteristics. So the 6 different types of winds are the polar easterlies or polar Hadley cells, the westerlies, trade winds or tropical easterlies, the doldrums, periodic winds, and local winds. And that is wind in a nutshell. A high pressure system develops, a low pressure system develops, and since air always flows from an area of high pressure to an area of low pressure, the wind that you feel is just air flowing from a high pressure to a low pressure system. Other factors are involved, obviously. Topography, when you live near a hillside, wind in the evening blows down the hillside due to gravity, so gravity plays a role. Also the hemisphere you live in play a role. Whether you're in the northern hemisphere and the Coriolis effect causes wind to deflect to the right, or in the southern hemisphere the Coriolis effect causes wind to deflect to the left. There are other factors involved, but if you look at the basics, air movement from a high pressure to a low pressure is what causes wind. I hope this has been helpful. If you didn't get what you want from this video, I left a link to the full article in the description below, so you can always read that if you need some more additional information. I hope this has been helpful. I hope you enjoyed this. So until next time, see you in the next video. Keep your eye on the weather. Cheers.